Well, now I am going to discuss about the conditional probability. It can be defined as possibility of an event or outcome happening based on existence of a previous event. It is a probability that is calculated using the previous events. And the mathematical representation of a conditional probability goes like this: P of A bar B, where P of A is a upcoming event and P of B is a previous event. And in simple terms, the P of A event depends upon P of B. And the equation for this goes like P of A intersection P bar P of B, where P of A intersection B is termed as a joint probability, whereas P of B is termed as a marginal probability. And a marginal probability is a probability that doesn't depend upon any conditions. It is an event that has already occurred. And P of A intersection B means the total number of common elements that are present in between A and B to the sample space. I'm going to discuss it in a further presentation. In a normal discussion, just take an example of a rain. We are able to predict the rain based on the clouds. If clouds are very dense, then the probability of rain is too high. That's what the presentation states. If we have dense clouds, then the probability of rain is 66%. Whereas if the clouds are lighter, then the probability of rain is much less. That's 33%. Now I am going to discuss it with a problem. Here we have given with a sample space that includes the 6 element 1, 2, 3, 4, 5, 6, and we have event A. Event A is equal to 2, 3 and 5. These are the prime numbers that are present in the sample space S. The event A includes all the prime numbers that are present in this sample space. And we have the event B. Event B includes 1, 3, 5. These are the odd numbers that are present in the sample space. And we have to find the conditional probability of event A with respect to event B if event B has already occurred. Let's look into the answer. We have the sample space equal to 1, 2, 3, 4, 5, 6. And we have the number of sample space equal to 6. And we have the event A that is equal to 2, 3, 5. And number of elements that are in the A set is equal to 3. And number of elements that are present in event B are equal to 3. And we have the A intersection B, means the common elements that are present in between A and B is equal to 3, 5, means number of elements are equal to 2. And according to the conditional probability, we have to calculate P of A bar B, that's equal to P of A intersection B bar P of B. And P of B can be calculated as number of elements in B to number of sample space. This formula I have already discussed while discussing the probability in the previous videos. And according to this, it goes like 3 by 6. 3 by 6 is equal to 1 by 2. And we have P of A intersection B. P of A intersection B is defined as N of A intersection B to N of S, means 2 by 6. Here we have the element N of A intersection B is equal to 2, and we have the N of S that is equal to 6. 2 by 6 equal to 1 by 3. Now we got P of A intersection B and we have P of B. And according to the formula, P of A bar B equal to P of A intersection B to P of B. And we have 1 by 3 divided by 1 by 2, that's equal to 1 by 3 into 2 by 1, and we have the answer as 2 by 3. And if we convert 2 by 3 in the decimal format, we are gonna get 0.66. In the percentage format, it is 66%. Just look over here. We wanted the occurrence of A with respect to B, means we have these elements 1, 3 and 5, and we have A element 2, 3 and 5. What are the common elements that are present in between A and B? That's 3 and 5. And what is the weightage of 3 and 5 in A? That is 66%, means 3 and 5 constitute 66% of this event A. And this is how we calculate the conditional probability. And let me take an example. If you consider 2, 3, 5 as a timing, these are the timing in which rain there are dense clouds. And event B is 1, 3, 5. These are the timing, like 1 p.m., 3 p.m. and 5 p.m. are the timing where the rain is gonna happen. And we have to predict whether the rain is gonna happen for this timing or not. Let's take example. Here in the B, we have 1, 3, 5 where dense clouds are happened, and in common we have 3 and 5 where dense clouds are happened, and we have event A where rain is gonna happen. Therefore, both are common where dense clouds are present and rain is probability of rain is gonna happen are more. Therefore, at 3 p.m. and 5 p.m. there are high possibilities that rain is gonna happen, and this is how we calculate the conditional probability. And after that, I'm going to discuss the real life example of the conditional probability by taking the example of prediction of the share market value of the Microsoft. We have two events, event A and event B. Event A suggests that there will be increase in the share market value of the Microsoft by tomorrow, and event B suggests that there will be increase in the share market overall share market value. And we have to find out the share market value of the Microsoft with respect to event B, that is overall increase in the share market. To find that, first of all we need to find whether what is the probability of getting both the value, like share market value of the Microsoft will be increased by tomorrow and overall share market will be increased by tomorrow. We have to find both the probability, because the first step to calculate the conditional probability is that we have to find the common probability between both the events, and it will be 0.80, and the overall share market will be increased by tomorrow is event B, that is P of B, that is 0.60. By dividing 0.80 to 0.60, we will get 1.33 as the answer. That means if there is an increase in the probability of the share market value of overall the share market, then there will be a 133% chance that the Microsoft share will be increased tomorrow. And this is how we go with the conditional probability. Well, do subscribe our channel for regular updates. Thank you.